The question we're asking today is whether the impression on the left-hand side is contained within the impression on the right-hand side. We're going to be using Photoshop to do that. And the first method I'm going to try is for Photoshop to auto-register the images, and that is to try to make them fit using its own automation. So what I'm going to do is go down to scripts, and we're going to load the files into a stack, which basically puts one on top of the other, and it's going to attempt to automatically align the source images. So I'm going to go find the images, and I've taken them left and right, taken them out and created separate files, and it's going to attempt to automatically align the images. So we'll go ahead and do that first. So you can see over here that we have one image file, and it's composed of two layers, the left layer, the left image rather, and the right image, left image being on top. That's all we can see. If we turn it off, we can see the underlying image on bottom of it. And what it attempted to do is automatically align. So it looks for features in common and attempts to align those features. The way we can see it a little bit easier is to go ahead and just slide the opacity of the top layer down, and you can see whether or not the points overlap. And it didn't do a very good job. So it would have attempted to auto rotate the images to make them align and somewhat manipulate them in a way that would get them to line up. But as we can see here, it didn't do a very good job. So if we look at specifically point 11 right here and the ridge that entails point 11, and we decrease the opacity and look for the same ridge on the bottom image, we can see that it's not a very good match. I'd venture to say more than anything, though, that perhaps the point designators, that is these little arms that come off the points, were probably considered too much in the attempt to align it by itself. So if that's the case, then we can go ahead and try to do it manually, because the difference between the two images, you can tell that they aren't exactly rotated in the same plane. So this has a little bit more of a flatter horizon than this one is tilted a little bit more. So I can go ahead and try to do that manually, and I would do that by not only rotating but perhaps adjusting perspective and whatnot. So I'm going to open up the two images again, this time as a stacked image that I already have. So again, the left image is on top, the right image is on the bottom here, and I'll go ahead and just kind of slide the opacity down a little bit so I can see the underlying, oops, wrong level, wrong layer that is, and so I'll slide them down a little bit in an attempt to align the points by stretching and warping the image to accomplish that feat. So we'll just go to Edit Transform, and first I'll probably go ahead and just skew it just a tad because it looks to be, actually I'll just rotate it first. So we'll rotate it to get the top image flow in the general area that we would want. And the way I'm accomplishing this is by, when the ridges become thick, like the ridges around here, you can tell that they're doubled. So that's a pretty good indication that they're aligned. So we apply, And then we can go back and slide the opacity up and down to see how good of an alignment that is. So we can see that it's not a perfect match by any means. The criteria I'm using to measure that is primarily the events that are marked. So like event 2 and 3 right here, pretty well stacked. So if I decrease the opacity and look at the underlying image, you can tell they're still off a little bit. So maybe let's go ahead and turn off the visibility of the layer so you can see it a little bit more drastically. So here, they're approximately right here, 2 and 3. Turn off the layer, they go over a bit. So just rotating the image is not enough to say that the ridges from the left impression align correctly with the ridges on the right impression. So what I would do in this instance, we could go to transform, and then we would have to warp it because they're not going to align perfectly through rotation alone. So you would have to stretch portions of the image to get them where they needed to be. So with this decreased opacity, I can see that 0.2 would have to come this way as well as 0.3. So I would take roughly this area over here, and we would want to do that till they approximately line up. But then that's going to cause some problems over here because the image is going to move accordingly to your warping. So we can see points 11 and 10 would then have to be stretched this way. And then down here, 7 and 6, 5 form a tight little triangular formation. And we can see that they 6 and 5, I believe that is, or 7 and 5 rather, line up. Once you make these warps though, then you have to go back and kind of fix them. It's not gonna only move the area you warp, it's gonna adjust surrounding areas, further areas a little bit less than closer areas, but still you're gonna have to go back and make sure that those align. And again, 0.4 here, we can see everything is shifted to the left. We're gonna have to bring this one over just a little bit. Actually, we're gonna have to bring it over to the right. And that roughly is going to give us some alignment. So if I accept the warp changes and then increase the opacity, we can see what the final product is. So we can see that it was rotated by the boundary of the image itself. Here's the background, which is a white layer. And then we can also see the curvature of the lines themselves indicate kind of how this top image was warped. So when we take it off, we can see that they're roughly in the same place, although not exact. There's not perfect alignment, but they're pretty good. But it doesn't appear, the bottom line is the evaluation would be that the image on the left is not a perfect containment by rotation alone of the image on the right. So the next thing we would do then would be evaluate the different elements of the two images. So this was the original image that was given. It shows a charting of the left impression relevant to the right impression. And so if we look at the different elements and impressions, we would expect to see some elements from the right impression in the left impression. And I say that because the right impression contains more information, so it would not be expected that this impression could create this impression and create more information than is what is present here. So the first thing we'll do is look at the image on the right hand side, and we'll look at the impression boundaries. So there are some clear impression boundaries. First one being denoted here in orange along the left hand side. Turn it off and turn it on. It looks pretty clear. The next one would be this area here. There's somewhat of a cutout area there, and a similar arc to the one on the left. So we can see that boundary there. Thirdly, there's an impression in the right-hand portion, upper right-hand portion. This would be expected in the impression boundary that would come from a finger area, the top of the finger area, when pressing down on something. So we'll turn those off and then turn them back on so you can see them again. The next thing we would be looking at would be voids in the ridge, because we would expect voids in the ridge. If this impression was cast and created this impression, we would expect voids in this area to be reproduced over here. So we'll look at those voids. Those are marked in green. So there's a void running through here. There's a void here, 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 and two long voids right there. We'll turn them off and on just so you can see them again. So we would expect those voids to exist in the same relative locations in the other print. Next, we would look at the distortion present in this print. So the distortion present here is largely notated by this yellow area that's somewhat opaque, so you can still see the underlying characteristics of the distortion. Distortion is noted by thicker ridges, areas that look somewhat like giraffe spots or alligator skin. They look rough and irregular, but you can see that in some instances they're clearly extenuating, or extensions rather, of the ridges themselves. So the ridge continues, however it takes on more matrix in this instance, and it appears thicker and in some areas distorted beyond recognition of ridges. So we'll turn that back on. And again, we would expect to see a ridge thickness reproduction in this area if this was truly the source of this, if the impression on the left was created through some sort of casting of this impression on the right. Something else to note, ridge number 10, event number 10, the ridge characterized by event number 10 and event number 1 has a certain measurement or a certain distance between the upper and lower ridges. There's a uniformity of distance there in the ridge. It looks to be fairly even, and that is just to be noted at this point. So if we go and look at those same elements in the left-hand side, the left impression now, we would see the boundary of the impression here, the impression shape in and of itself looks pretty regular. And one way to really characterize that would be to go to the image itself, and then if we just affected this side only, we adjusted the threshold. Threshold is just going to take values of white and dark, or white and black, and you tell it where to set the threshold. Anything above is going to be clipped to white, anything below is going to be turned black. So we can really kind of see the boundary jump out at us as we manipulate the threshold level. So we can see it's pretty uniform here going around, and that's what's shown here by this orange ring. Over here, the voids on this impression, which are analogous to the green areas over here, primarily exist right here and right here. This void here is somewhat analogous to this void and could be really a break in the ridge. I mean, it's not able to be distinguished just from the impression itself or two impressions themselves. Another void exists right there. I'll turn them off and turn them on so you can see them. But largely the ridges on this impression are continuous, more so than the image on the right. Distortion area in the left impression primarily confined to a lower circular area in the middle. Turn that off and turn it on. Ridge area appears, or the ridge deposition, the deposition of the matrix appears to be somewhat thickened by that area there, or in that area. Then taking the ridge that is characterized by event number 10 and event number 1, we look here. And this time when we trace the ridges above and below, the spacing of the ridges looks to be bunched up right between the ridge segment characterized by event 10 and 1 and the lower. It looks pretty uniform to the upper ridge, but lower it looks to be a little bit squashed. The distance between the two appears to be diminished somewhat. Not something that you would expect if this had been cast to create this impression. You would expect the uniformity, unless the structure or the material that the cast was made out of was flexible. So I mean, it's possible, but in a straight rigid cast like a plaster cast or something of a harder surface, a harder nature, you wouldn't expect there to be deformation of ridge spacing from one to the other. So lastly, the way we analyze the print would be to take a look at a 3D spacing of their a surface plot, kind of a 3D histogram. So what we can do is we'll take the left image and we'll do a surface plot histogram here. And that's going to show us, basically, it's similar to the histogram in Photoshop, but just in it's represented in a 3D format. So we would look for consistencies between the two. And they would be relative consistencies, because obviously the dark and light values, the grayscale values for the image on the left are going to be different than the image on the right. But they should show relative areas of similarity, just in terms of a pattern. So look at the one on the right of the surface plot. And we see different patterns. This one is a lot more scattered, and which is to be expected, because the dark and light values are represented here are, it appears to have been enhanced, or the contrast has been enhanced in some sort of digital imaging program. And so we can see that we would expect to look for some sort of similarities in the histogram, not a one-to-one identical plot necessarily, but some similarities, and those similarities aren't necessarily there. And lastly, going back to this, the distorted areas in the right impression would expect to be correlated to ridge thickness in the same areas. So we can see that, for instance, characteristics 2, 3, and 4 live in this zone, so we would expect areas surrounding those to be thicker due to the nature of the thickness and the impression on the right. And we don't necessarily see that. So lastly, the disclaimer, it would be that these are not original source images. The analysis represented here is subject to having only the available materials, and that's this image here. So if I had different images, or even the source material themselves from which I could create images myself, an analysis may be different. But given what I've seen here, they do not appear to have come from, well, the image on the left does not, the impression on the left does not appear to have been sourced by the impression on the right.